Hi students, so let us start studying motion in one dimension today. Motion in one dimension is the first conceptual chapter in +1. Before that you have some introductory chapters, but the real concepts of physics in detail will start from motion in one dimension. So we will see the introduction, what is motion in one dimension, what all things to be learned in this chapter, and understanding of basic terminologies and concepts. So let us see. Motion in one dimension actually discusses about any particle which is in straight line, whether it is horizontal or if it is vertical also, it comes under motion in one dimension. What about this type of motion? This is also straight line, this is also motion in one dimension. Why we say dimension? What is dimension? Suppose if we consider this as our point of observation. For example, if we are observing from this point, we can observe from any point, wherever we are, we can observe from that point. Suppose if this is the point of observation, if a particle or object is here, we can convey the address of this object in many ways. If your house is in some street, you will say house number 2 and Bangor Street, Kaundampalayam, Coimbatore. Likewise, you can give some address. That address is quite understandable for a common man, for a layman. Someone studying physics, they have the terminologies related to physics. For example, if you are observing from Earth, we are observing from Earth. If this is a satellite, then the position of satellite we will tell with respect to Earth. We cannot have address at every point where satellite is moving. Quite understandable. So there, how we can say, we can say from this point, if we consider this as x-axis, if we consider this as y-axis, if we consider this as z-axis, since I cannot draw this on the board, I will be drawing like this. So if the satellite is somewhere here, see, this is the plane of the board. If the satellite is here, the satellite is in the plane of the board. Need not be like that. It can be like here. So this distance is nothing but z. Suppose if this distance is 2000 kilometers, just for example, and if this distance is 3000 kilometers, and this distance, if the satellite is here, this distance, if I say this as 1000 kilometers, then I will be able to say the position of the satellite with respect to me is like x, y, z. I can say 2000, 3000, 1000. So here I can say this is 1, 2, 3, three-dimensional specification of position of an object. Hope you understood. Now, if the satellite is moving, I need to mention one more thing. Satellite was at this position at a so and so time. So if I add one more dimension of temperature, time, x, y, z, t. So I say 2000, 3000, 1000. then I am writing 1000 seconds. So from the time I start observing, at the 1000th second the satellite came to that position. So this can be explained in many ways, all with respect to how we take, based on my convenience. Okay, so this is 1 2 3 4 dimensions. So with this 4 dimensions I am able to specify the position of a satellite. This is what is dimension. You can have many dimensions also. You can have 4th, 5th, 6th, 7th, likewise you can have many dimensions. So when we say motion in one dimension, only one dimension with respect to distance will be varying. I will explain. Suppose a particle is moving like this. Suppose a particle is moving like this. If I draw a graph y, x. So if the value of y is 2 meter, here y value is not at all changing. Only x is changing. 1 meter, 2 meter, 3 meter, 4 meter, 5 meter. Likewise, only x is changing. This kind of situation, this is example for motion in one dimension. Now suppose if I draw like this, and if some particle, if I threw a ball upward, the ball is moving up. If I mention like this is y, this is x. Only y is changing there. That is also motion in one dimension. So in motion in one dimension, we are able to move only in horizontal direction and vertical direction. Is there anything like that? Just see this. Suppose a particle is moving like this, and I am drawing a graph like this, x, y. It's my wish. This is also motion in one dimension. See, when I say I am drawing a line like this, I am standing in India, in Tamil Nadu or Kerala or anywhere, I am drawing like this. For someone on the other side of the globe, or someone on the different sides of the globe, this could be some other axis, can be some other direction. So it is our convenience, we are taking x, y, then plotting a direction of motion. So all straight line motions are motion in one dimension. Just I have explained the heading of the chapter. So fundamentals of physics starts from this chapter. Those who study motion in one dimension very well, only that person will understand motion in two dimension. So someone who studies motion in one dimension and two dimension, for them work power energy will be a little more comfortable. Likewise, we should put the basics fundamental strong, and if we further move, then we will be able to follow physics well. So be careful, understand it very carefully with the interest. Motion in one dimension, we will be studying basically 5 terminologies, 5 concepts or 5 physical quantities as fundamental concepts. So number 1, distance. Number 2, displacement. Number 3, speed. Number 4, velocity. Number 5, acceleration. Distance, displacement, speed, velocity, acceleration. If we understand these 5 terminologies, then only we will be able to move further. If we understand this, again we can further build our fundamentals on further topics. But if you don't understand this, then we won't be able to study further well, and understanding and studying will make our studies very easy. So these 5 concepts we will discuss now. Say, if this is, for example, Coimbatore, and this point is Chennai. Now we have different routes to move from Coimbatore to Chennai. So one person took this route and he reached here. He took around 500 kilometers. Example. Another person took a route like this and he took around 350 kilometers. Another person took a route like this and he reached by around 300 kilometers. Now from Coimbatore to Chennai, 3 different routes. Among them, which is distance and which path is displacement? This path is also a distance. This path is also distance. This path is also distance. You have studied these fundamentals in your 9th, 8th, 9th, 10th, although you study some physics now. So you must understand, actually these are distances. Thus all these 3 are, none of these 3 is displacement. Displacement is nothing but, from here if I draw a straight line, this is called a displacement. So path number 1, path number 2, path number 3, path number 4. So I can say distances are 1, 2, 3 and 4. So this displacement path number 2, this is also a distance. Displacement is also a distance. 1, 2, 3, 4, all these are distances. Displacement is only one, that is path number 2. That is shortest straight line path from initial position to final position. So this is initial position and that one is final position. So initial position, then final position. We must mark initial position and final position, draw a straight line, that will give us displacement. So any path from initial position to final position are displacement. The shortest straight line path from initial position to final position is what? Displacement. Okay, so pause the screen, copy the diagram and so displacement is the shortest straight line path from initial position to final position. So this is the difference between distance and displacement. Must be very careful regarding this fundamental basic concept. Now distance and displacement both of their units are meters. Meter. Okay, distance and displacement both have same unit, meters. Now, what is the difference we understood? One is shortest straight line, another is any path. All the physical quantities in physics we can divide into vectors and scalars. So something which has got only magnitude, those kind of physical quantities are called scalars. Physical quantities with the direction as well as magnitude, we call them vectors. I'll explain. See, suppose imagine yourself in front of me. Your friend is on the right side, your friend is on the left side. Now suppose if I am punching you, so someone is behind you also. Suppose if I punch you, getting my punch, you fall down backwards, the friend in sitting backwards on back of you, he or she also will fall down. The adjacent friends, they are sitting on the right and left, they will be laughing. Okay, because they are not affected with my punch. What I am doing, I am applying force on you, and this force has a direction and magnitude. What is magnitude? If you go to a shop and if you ask 5 kg apple, I need 5 kg, 5 kilogram apple. So that 5 is what is magnitude. Kg is unit. When I say 5, that is what magnitude. A number, size or any numerical value. So if I hit you with the 5 Newton, Newton is the unit of force, 5 is the magnitude. Now in which direction I am punching you? I am punching you in this direction. So direction can be mentioned in many ways: northward direction, south, east, west. Likewise I can write, or otherwise if I consider like our Cartesian coordinate x, y, z dimension, I can say like I punched in x direction. Likewise, so force you understood, right? That has got magnitude and direction. Those kind of things are called vectors. Okay, something scalar, vector. So something with the magnitude and direction. Okay, something with the magnitude and direction. Scalar, only magnitude. Vector, both direction and magnitude. Example for vector we saw force. Force is example for vector. Now suppose our classroom, I increased the temperature of the classroom by some technique. Classroom was around 25 degrees Celsius. When I increased the temperature of classroom, it becomes 35 degrees Celsius, 40 degrees Celsius, 45 degrees Celsius. Now only one person is affected, or the whole class is affected? The whole class will be affected. All of you, including me, will be under panic mode. So here this temperature is not acting in a particular direction. It is affected for all of us. So 45 degree is having a magnitude of 45. But whether it is affecting in any direction? No, it is not affected in any particular direction. So for scalar, one example we can write is temperature. So difference between scalar and vector. Example for vector is force, example for scalar is temperature. How we can put this concept into distance and displacement? Suppose if we take an initial position, if we take a final position, and this is a path, this is another path, this is another path. Okay, initial position, final position. You consider this point, direction of travel is this direction here. If we consider this point, direction of travel is this. If we consider this point, direction of travel is here. So this is what? Actually this is distance. We have seen this is distance. No particular direction, no specific direction for distance. If we consider this point, direction of travel is this. If we consider this point, direction of travel is this. See? So this is displacement. Very clear. Displacement has got a specific direction. So we can say displacement is vector, distance is scalar. This vector scalar, just as an introduction, we are mentioning here just to say that distance is scalar and displacement is vector. A detailed description, detailed analysis and study of vector and scalar will come in motion in 2 dimension. Okay, so first 2 concepts in motion in 1 dimension, basic terminologies. Distance, displacement we have studied. Distance is any path covered by a moving object. Displacement is the shortest straight line path between initial point and final point. Distance is a scalar, displacement is a vector. Displacement is a vector. When we say that, vector is nothing but a physical quantity which has got direction and magnitude. Magnitude is some number, direction we know a specific direction. When we say distance is a scalar, it means distance is having only what? Magnitude, no specific direction. Direction is there, but it varies. Okay, so this is what the difference between distance and displacement. 3rd point and 4th point were, 3rd point was speed, 4th point was velocity. So that we will see after seeing some problems on distance and displacement. So speed, velocity, acceleration is pending. Let us see some problems on distance and displacement. Okay. Now see, one particle is doing circular motion. So it started from here. Okay, started from point A, moved and reached point B. Okay, radius of this circular motion, if we write 10 meter, if we take, then what is the distance? What is the distance? What is the displacement in this question? Okay, a particle is making circular motion. It starts from A, reaches B. So this is the starting point and it reaches B. So what is the distance and displacement? Given radius is equal to 10 meter. Okay, how to do this problem? So distance, what is the distance here? I will show you. This is what is actually distance. This is what is actually distance. Distance. Okay. So full distance, if the particle is making full circular motion, then we can say distance is what? Full circular motion means it is perimeter. The formula for perimeter is 2 pi r. So we can write 2 pi r if it is making full circular motion, if it starts from here and returns back here. But here it travels only a quarter length. So we can write 2 pi r by 4. So this is nothing but pi r by 2. So r is given as 10. So we can write 10 pi divided by 2. We can write 5 pi. So based on the option we are getting in the question, either we can mark 5 pi, or if they have simplified, we can simplify it and give. The options will be given like this, no? 5 pi option B, 10 pi option C, 2 pi option D, 0, something like that they will be giving. So distance, this is the correct answer. Okay, now displacement. How to find displacement? Displacement is nothing but the shortest straight line path from initial position to final position. This is the initial position, this is the final position. Shortest straight line path. Draw a straight line. This is the direction of displacement. Now how to find this? If this is radius r, this is also radius r, this is also radius r. Now we can apply here what? Our Pythagoras theorem from mathematics. So displacement is equal to root of, this is, we need to find this. This is x and this is y. X square plus y square. R square plus r square. So this is going to be 2r square, or we can write root 2r. So r is given as 10. So option answer will be like 10 root 2. 10 root 2. So answer is 10 root 2. So this is how we can find distance and displacement of this question. Pause the video, note down the solution. Another question. Suppose if a body starts from point A, it goes to point B, returns back to point C. We are asked to find distance and displacement. So what is the distance here? It traveled from A to B. So that length is 10 meter. That is there. It returns back to C. That is also, it has traveled. So total distance is 13 meter. What about displacement? Travel from A to B, total is 10 meter. It came back to C. So initial position is this, final position is this. Displacement is the shortest straight line distance between initial position and final position. So from 10 meter, if you reduce this, this is going to be 7 meter, and we can write this is 7 meter. So this is the distance and displacement of this situation. Next question is, we need to find the displacement of point of a wheel initially in contact with the ground. Say for example, we have cars, cycles. So this cycle and cars will be moving. So that there will be a circular motion also in that wheel, and there will be a linear motion like this also. So here I will give you a small introduction about the types of motion we will see in physics. There are different types of motions. So just giving a small introduction to understand this question. One motion is translational motion. Translational motion. It is like this is my palm, okay, this palm is moving like this. Translational motion. Another is Circular motion, see cap of this pen moving like this. Circular motion. Now there could be different types of motion like vibrational motion, simple harmonic motion, everything we will study later. So suppose a wheel of a car, if we take, it will be doing circular motion also. At the same time, while doing circular motion, it will be moving further. So that is translational motion also. That is a type of motion wheel of a car, bike or cycle will do. Okay, so we need to think like that while doing this problem. Okay, look at the question. What is the displacement of point of a tire of a car initially in contact with the ground after half a rotation? Radius of a tire is r. Okay, so options are pi r, 2 pi r, pi into r square plus 4, r into pi square plus 4. So pause the screen, think for some minutes, try to solve this question. Okay. How the situation will be. Suppose if this is wheel of a car, what they are asking, displacement of a point of a wheel initially in contact with the ground. Which point is initially in contact with the ground? This point. This point is what? Initially in contact with the ground. After half a rotation, after full rotation, obviously this point will come on the ground. This point will come on the ground. After half a rotation means this point will come on the top like this. What they are asking, what is the displacement of that point after half a rotation? So displacement is the shortest straight line path from initial point to final point. If this is the initial point and if this is the final point, then if we mark a straight line like this, this is what is displacement. We had the options like pi r, 2 pi r, pi into root of r square plus 4. Option D was r into root of pi square plus 4. These were the options. Now how to find? Radius of the wheel was given as r. Now if we take like this height is nothing but 2r. What about this distance? If the wheel has rotated through this ground like this, this point has reached here on the top. So this much distance the wheel will travel through this, so that this point will come on the top. What is this distance? This distance is nothing but pi r. Now how to find this? Pythagoras theorem. So displacement x is nothing but 2r the whole square plus pi r the whole square. Now this is nothing but 4r square plus pi square r square. So if I take r square out, I'll be getting pi square plus 4. Now r if I take out, I'll be getting, when r square comes out of the root, this will become r. So r into pi square plus 4. This is the answer, option D. So this is a very good question. If you don't understand, play it again, see this, make the things very clear, then settle it and further proceed. Next concept is speed and velocity. So speed is nothing but rate of change of position of an object when it is moving, rate of change of position of an object when it is moving through distance. That is, speed is nothing but distance by time. So when an object is moving through a distance, actually it is changing its position. So position can be changed through distance as well as through displacement. So speed is nothing but distance by time. So we know the unit of distance is meter, the unit of time is second, so the unit of speed is meter per second. What about velocity? Velocity is displacement by time. Displacement by time. What is the unit of displacement? That is also meter. Unit of time is second. SI unit of time is second. So the unit of speed as well as velocity is, they are same, meter per second. But speed is distance by time. Now you know very clearly now what is distance. So distance by time. Velocity is nothing but displacement by time. So this is the basic idea of speed as well as velocity. Now we will understand the concept of speed and velocity a little more detailed way. So example for scalar, we have seen temperature, vector we saw, force, punch, distance is also scalar, no particular direction, displacement is vector, speed is also scalar because speed is nothing but distance by time. Here distance is scalar we know, so speed is also scalar. Velocity, velocity is nothing but displacement divided by time. Now this displacement is a vector that has got a direction. So velocity is also a vector. So what direction velocity will follow? Velocity will follow the direction of displacement. Velocity will follow the direction of displacement. Okay, so we got idea about the speed and velocity in terms of vector and scalar. For velocity, we can say in this way also, delta x by delta t. Delta x is nothing but change in position, delta t is nothing but change in time. How we can see just by putting a practical situation. Suppose x is position, t is time. Now suppose if I am your friend, assume that I am your friend, and suppose if your name is Vimal. Now Vimal is my friend, Vimal is moving away. So at 9 o'clock, see time 9 o'clock. At 9 o'clock, Vimal was standing with me. So his position from me is 0. He is near me, so he is not away from me. So his position is 0. Now I am the origin, I am the observer. you have seen graphs. We put origin here. What is this origin? We used to ask this question in the classroom. We will be getting different responses. Some of students will say this is a starting point. Some answers will be like this is center of earth. Lot of weird answers will be coming. No problem. We should understand, we will learn. So what is this origin? If it is a starting point, see, suppose something is coming like this, then this is the starting point. So it is not like that, this is starting point, and this is not center of earth also. What is this origin? Origin is actually observation point or observer, or we can say observation point simply, because when I say at a time t is equal to 9 o'clock, the position of an object is 0, means the position of the particle is at the origin. In this case, it is starting from here. Need not be always 0. If I put 1 meter, it shows that at 9 o'clock, the particle is 1 meter away from the origin. 1 meter away from the origin. Why I have taken 9 o'clock? The observer decided to look at the object at 9 o'clock. It can be 8 o'clock also, if the observer started looking at the object. For example, this person, observer, I am observing Vimal. I started observing Vimal at 9 o'clock. So time t I have taken as 9 o'clock. When we put here t, when I put here t, and if I am putting here x, I put here as 0 second, 1 second, likewise we plot in the graph. Why? Because I have taken 0 time as 9 o'clock. I can put 10 o'clock also. So I have started observing Vimal at 9 o'clock. So this time is actually taken as origin. Okay, since I am observer, I have taken as 0. Likewise. So in physics, in one-dimensional motion, two-dimensional motion, every questions that we are getting will have an observer in assumption. Based on that observer only, we will be able to frame questions. So this must be a basic understanding. Okay, clear? Now let me explain. So one person was with me, Vimal was with me at 9 o'clock. Now after 9 o'clock, 0.1 second, Vimal went to a position 5 meter away from me. So he is moving in a straight line. After 1 second, he was at 5 meter. Then at 9 o'clock 0 minutes 02 seconds, now his position is 10 meter. 9 o'clock 0003, his position is now 15 meter. Now what is his velocity? I can say velocity is displacement by time. Displacement is nothing but change in position. I can write displacement by time. So this displacement is nothing but change in position. I said delta x by delta t. We will see now delta x. If I take these two intervals, this is nothing but here x2, this is x1. So x2 I can take as 5 minus x1 is nothing but 0 divided by 9 o'clock 0.1 second minus 9 o'clock 0 second. So the difference is here 1. So velocity is 5 meter per second. Now if I take another interval, this interval and this interval I can take, it's my wish. V is equal to x2 here it is x2, I consider this as x1. I can write 10 meter minus 0 divide by here 9 o'clock 2 seconds, here 9 o'clock 0 seconds. So the time duration is 2. Again I am getting 5 meter per second. So I can take any interval, you can take any interval between this and this, between this and this, between this and the last one, any interval you can take. How to find velocity? Change in position by change in time, x2 minus x1 by t2 minus t1, or delta x by delta t. If the displacement is directly given, you can take displacement by time. So this is what is velocity. By observing this, we will be able to understand how fast Vimal is moving from me, or how fast the object is moving away from the observer. So this is how velocity is. Okay, hope you understood. Pause the screen, note down. Now we have seen distance, any path followed by the object. Displacement is the shortest path from initial position to final position. Unit of both the distance and displacement are meters. Distance is scalar, displacement is vector. We have seen speed. Speed is nothing but distance by time. Velocity is displacement by time. Speed is scalar because distance is scalar. Velocity is vector because displacement is vector. Unit of speed and unit of velocity both are meter per second. One more thing which we need to see is dimension. Dimension is nothing but by using the basic fundamental units, we will understand the dimension of a physical quantity. See, velocity. Velocity is what? Displacement by time. So displacement is nothing but length, time is nothing but t, so L t raised to minus 1. So this is the dimension of velocity as well as speed. If speed is there in the place of displacement, what will be getting? That will be distance. So distance by time, again same thing. So this is the basic difference between velocity and speed concept. Okay.